Let us consider first what we mean by time. What is time? It would be nice if we would find a good definition of time. Webster defines a time as a period, and the letter is time, which doesn't seem to be very useful. Perhaps we should say, time is what happens when nothing else happens, which also doesn't get us very far. Maybe it is just as well if we face the fact that it is what we already know it to be. It is how we measure it. One way of measuring time is to utilize something which happens over and over again in regular fashion _ something which is periodic. For example, a day. A day seems to happen over and over again. But when you begin to think about it, you might well ask, are days periodic? Are they regular? Are all days the same length? One certainly has the impression that days in summer are longer than days in winter. Of course, some of the days in winter seem to get awful long if one is very bored. You have certainly heard someone say, "My, but this has been long day." It does seem, however, that days are about the same length on the average. Is there any way we can test whether the days are the same length, either from one day to the next, or at least on the average? One way is to make a comparison with some other periodic phenomena. Let us see how such a comparison might be made with an hourglass. With an hourglass, we can create a periodic occurrence if we have someone standing by it day and night to turn it over whenever the last grain of sand runs out. We could then count the turnings of the glass from each morning to the next. We would find, this time, that the number of hours that is turnings of the glass was not the same each day. We should distrust the sun or glass or both. After some thought, it might occur to us to count the hours from noon to noon. We would find, this time, that the number of hours each day is same. We have some confidence that both the hour and day have a regular periodicity that is marked off successive equal intervals of time, although we have not proved that either one is really periodic. Someone might question whether there might not be some omnipotent being who would slow down the flow of sand every night and speed it up during the day. Our experiment does not, of course, give us an answer to this sort of question. All we can say is that we find that a regularity of another kind fits. We can just say that we base our definition of time on the repetition of some apparently periodic event. These all we talked about basic definition of time which is in our daily practice. Now from another perspective, or from the Einstein's perspective of time. According to Einstein, time is a variable. It can change and it can be responsible for the change of other dimensions in space. Through his special theory of relativity, time is relative, not an absolute constant. The speed of light meant that time can run faster or slower depending on how fast you are traveling. Time gets slowed down when you move with the nearly speed of light. It is called time dilation. We have a one-thought experiment that can better explain the time dilation as twin paradox. It's exciting, isn't it? Only this much for today. We will be bounced back with the new topic, none other than twin paradox. So guys, subscribe the channel and press the bell icon to stay tuned and never miss the update. Keep shining and keep watching Physics Maths World. Okay, ta-ta, bye.